The chapter 6 review packet. I'm going to work out the problems. You can use what you want off of it, skip through it. In case you have trouble with a certain problem, you could look through this video. And I'm going to move extremely quickly to try to make it as short as possible. Number one, they tell us that this segment is 24, this segment's 24. This is a right angle. They want us to find the length of segment BC down here. Well, if these two are both 24, then that means this, with that being a right angle, has to be the perpendicular bisector of segment BC. Well, if it's the perpendicular bisector, then this segment's 15. That means this part's got to be 15. They want the whole thing, which is 30, and that would be answer B. Number two, they give us something that looks like this. Again, they give us that. That's a right angle. These two are congruent, they tell us. So that means this is the perpendicular bisector. If it's a perpendicular bisector, then point A up here has to be the same distance from B as it is from C. That's what our theorem said, that those two distances have to be the same. They told us this distance was 4x plus 6. This distance was 5x minus 6. So those two distances have to be the same. So we can set those two expressions equal to each other. So 5x minus 6 has to equal 4x plus 6. Subtract 4x on both sides. You end up with x minus 6 equals 6. Add 6 to both sides. You end up with x equals 12. And they ask us to find the length of segment AB, which is this segment over here. So I'm going to take that 12 and I'm going to stick it right back in there. 4 times 12 is 48. 48 plus 6 is 54. So the length of segment AB is 54, which is letter C. Number 3. They give us this picture. And they tell us that this is D out here. And again, I'm not drawing all the pictures completely. That's a right angle, that's a right angle. They tell us this is 7, this is 7. We had a theorem that said, the converse of the angle bisector theorem, that said if this point is the same distance from the two sides of the angle, then this must be an angle bisector. So it must split this angle into two equal parts, even though my picture doesn't look like it. They tell us this part over here is 23. Well, if that's an angle bisector, then that means the other angle over here has to be 23, which is letter C. Number 4. Number 4 looks like same idea. This time they tell us that that is an angle bisector, so those two angles are congruent. And then we have something that looks like this and something that looks like this. This point right here has to be the same distance from that side of the angle as it is from that side. They tell us this is 6x plus 3, and that this is 3x plus 6. So we set up an equation. 6x plus 3 has to equal 3x plus 6. Subtract 3x on both sides. You end up with 3x plus 3 equals 6. That's an equal sign there. Subtract 3 on both sides. End up with 3x equals 3. Divide by 3, end up with x equals 1. They ask us to find the length of segment BD. BD is this segment right here. So I'm going to put 1 back in there for x. So 6 times 1 plus 3. BD is 9. Which is letter C. Number 5. Number 5 says, find the coordinates of the midpoint of segment AB if A is -4, 0, and B is 8, 3. Midpoint formula looks like this. X plus X divided by 2. Y plus Y divided by 2. Two separate parts there. Remember, this is an X, that's a Y, that's an X, that's a Y. So I'm going to stick in -4 plus 8. That's our X's, divided by 2. Then our Y's are 0 plus 3, divided by 2. -4 plus 8 is 4. 0 plus 3 is 3. 4 divided by 2 is 2. 3 divided by 2 is 1.5 or 1.5. See if that answer's on there somewhere. Yeah, it looks like letter C. Number 6. Number 6, they give us a triangle. Again, I'm not drawing all of these pictures. On this one, they tell us N is the end center. Well, if it's the end center, we had a theorem that said the end center of a triangle. Number one, it bisects the angle, so we know it comes over here to this angle, if I could draw it, and makes those two angles congruent, but that doesn't help us in this problem. But we also know we had the theorem that said the end center has to be the same distance from that side of the triangle as it is from that side, as it is from that side. So all three of those have to be congruent, even though my picture looks absolutely nothing like them being congruent. This is D, this is F, this is E, and they tell us that ND is 4x plus 5, and NF is 7x minus 10. So we know that those two things have to be equal to each other. So 7x minus 10 has to equal 4x plus 5. Again, the theorem says the end center of a triangle has to be the same distance from all three sides of the triangle. We solve that, subtract 4x on both sides, you end up with 3x minus 10 equals 5, add 10 to both sides, you end up with 3x equals 15, divide both sides by 3, end up with x equals 5. They ask us to find the length of segment NE. Make sure you read the questions carefully. They didn't just ask us to find 5, find x. They wanted us to find the length of segment NE. Well, NE is this segment right here. They didn't tell us anything about it, but we know it's the same as these other segments. So if I just pick one of them and plug in 4, put 5 in place of x, plus 5, 4 times 5 is 20, plus 5 is 25. So NE has to be 25, which in this case is letter D. Number 7, they give us a triangle, looks something like this. Again, my triangle might not look perfect. They tell us that P right there is a centroid. If P is a centroid, then that means that that point, and that point are midpoints. Don't get medians and mid segments confused. These are medians this time. So those are midpoints. They tell us that segment BP, which is B is right here, is 3, and L is down here. Well, we had a theorem that said if this is 3, this part here has to be double that, so it has to be 6, and so that means segment LP is 6, and that's a 6. And then we know that this whole segment LB or BL, has to be those two added together, which is 9. So 6 and 9, looks like our answer should be A. Number 8, same idea on number 8. They tell us at that point right there is a centroid. They tell us that segment AN, this is A, that's N. They tell us that that whole thing is 18. Well, what you could do is split it up into thirds. So 6, 6, and 6. The shorter part has to be one of those, which is 6. The longer part has to be double that, which is 12. So segment AP is from here to here is 6. Segment NP from here to here is 12. Let's see, that's letter A. Number 9. They said Park and Recreations Department wants to add some sidewalks to the park. F is a fountain. We got something like, looks like this. And then F is right in here, and that's the fountain. This is the gift shop. This is the snacks. This is A, which is the entrance. That's where you enter at. This is zoo up here. This is B over here. And they tell us that F is the centroid. Well, that means that each one of these is a median. So we can use those theorems. We know that the distance from the snack bar to the entrance is the same as from the entrance to the zoo, which doesn't really help us in this problem, but we know that's true. We know these two distances are the same. And this down here is C. We know that this distance is the same as that distance. C's got to be a midpoint there. They tell us that F to the entrance is 85 feet, so this right here is 85 feet. They want to know how much sidewalk they need to put on this path right here. Well, it's got to be double whatever that is, so we just take 85 times 2, gives you 170 feet, so they need 170 feet of sidewalk for that part, which is letter C. Number 10. Remember on this, those were all medians. On number 10, they connect that point to that point, and they tell us that these two are congruent, those two are congruent. That's a mid-segment. Medians and mid-segments, two different things. Support the mid-segment, find the value of X. They tell us that this here is 21 feet. X is right here. We really don't have to do anything with the mid-segment. We just know that down here, this is a midpoint, so if that's 21, X has to be 21, and that's letter C. Number 11. Number 11, they give us a picture, it looks like this. And my pictures might not look the greatest. That's 21, this is 19, this is 17. You install fencing around your large triangular garden, then you divide it into 4 smaller triangular gardens by connecting the midpoints. So each one of these points right here is a midpoint. That means each one of these segments is a mid-segment. Well, if this is a midpoint, then we know that's 17. This part up here has to be 17. This is 19. This part has to be 19. And we also know that this whole thing is 38. That means this mid-segment right here has to be half of that, which is 19. This whole thing is 34. The mid-segment that's parallel to it, which is this one, has to be half that, so that's 17. This is 21, so we can find this whole thing out here by doubling that, or putting 21 here, and that whole thing is 42. I'm not sure what they've asked us to find yet, but we know all that information. It says, how many feet of fencing do you need? You're dividing it into 4 smaller triangles. You install fencing around your large triangular garden, then you want to divide it into 4 smaller triangles by connecting the midpoints of each side with the fencing. So we're fencing in this whole outside, which is 42, 34, and 38. And then we're also fencing in these 3 parts. So 19, 17, and 21. We got to add all those up. That's 6, 14. 14 plus 7 is 21, 31, carry the 3, 7, 10, 13, 14, 15, 16, 17. So we need about 171 feet of fence, which is letter C. Again, on that one a little harder because you had to find this whole distance all the way around the big triangle and then this distance around the little triangle. Number 12 says, list all the sides from shortest to largest. So we're going to list all the sides shortest to largest. So I'm going to use the less than symbol. Shortest going to go over here, largest over there, and then the one that's in the middle there. This is 63 degrees, that's 60 degrees. First thing we got to do is find this missing angle, and we do that by adding those two. That's 123. Then we subtract that from 180. You get 57. We had a theorem that said the biggest angle, or let's start with smallest since we're starting with smallest. The smallest angle has to be across from the shortest side. So that means this side over here, AB, has to be the shortest. The next shortest is that one, which is segment AC. And then the longest side is this one, which is segment CB. All right, no talking. All right, I can't remember which problem I left off on, so I'm just going to guess. And we're going to do problem number 10. If I skip some, then I skip some. You can figure them out on your own. Problem number 10, they give us a picture. It looks like this. I'll probably remember here in a couple minutes which ones I did and which ones I didn't do. But if I repeat any, it's not a big deal. Just skip over them. They tell us that this is a mid-segment. That means this segment has to be congruent to that segment. These two segments are congruent. Then we know that if this is a mid-segment, then it's got to be half the length of this segment, which really doesn't help us in this problem because they told us this was 21 feet. This is X, so all we really need to know here is that those two have to be the same. So X has to equal 21, which is C. Number 11, they give us a picture that looks something like this. It says you install fencing around large triangular garden and you divide it into 4 smaller triangular gardens by connecting the midpoints. So we're connecting all these midpoints. And we're going to fence in that. So we're going to fence in the big triangle. We're going to fence in this small triangle. We want to find the total of all those. They tell us that this is 21. This is 17. This is 19. See anything else there? Looks like that's all that they tell us. If each of these is a midpoint, then if that's 17, this has to be 17. That means that whole thing is 17 plus 17, which is 34. That's a midpoint. So if that's 19, this is 19. That whole thing then is 38. We can also do this. If that's a mid-segment, it's got to be half as much as that segment there. Well, half as much of that is 19, so we can write that in there. This is a mid-segment. It's got to be half as much as that one, so that's got to be 17. This is a mid-segment, so this segment over here, the whole thing, has to be twice as much as that, which is 42. Each of those parts is 21, which really doesn't help us. We want to find the fence around the big triangle. So that's the first thing I'm going to do is find the fence around the big triangle. And I'll just write big triangle here. We're going to add up this side, which is 42, this side, which is 34, this side, which is 38. We're going to add all those up. That's 14, 7, 8, 9, 10, 11. That's 114. So that's how much fence it's going to take to go around the big triangle. Then we also want this smaller triangle in here. We want to fence it in. We want to fence it in. So we got 17, 19, and 21. We're going to add all those up. That gives us 17 there. 1, 2, 3, 4, 5, 57. Then we're going to add that 57 to the 114 to get the total fence. That looks like it comes out to be 171 feet of fence that we need, and that looks like, what is that, answer C? Next one, number 12. They give us this triangle, A, B, C. This angle's 63 degrees. This angle's 60 degrees. As soon as I see that, first thing I want to do before I even read the problem is figure out what the third angle is. I don't know whether we'll need it or not, but might as well figure it out. Those two added together is 123. Subtract that from 180. You get 57, so this angle's got to be 57 degrees. And it says, list the sides of the triangle from shortest to longest. So we're going to list them. I'm going to use the alligator mouse. Shortest one over here, longest one over here. We can tell that by looking at the angles. The shortest side's got to be across from the smallest angle, which is 57. So segment AB has to be the shortest. The next smallest angle is a 60 degree, so that's across from AC, so that's the next shortest side. And then the longest side has to be over here across from the 63 degree angle, which is that right there, which is BC or CB, whichever one they name it. If we look at the answers down there, the first two have segment AB first, then letter B's got AC, then CB, so they just got this one turned around, same thing. So our answer there would be B. 13 looks like the same kind of problem, only this time they give you all the angles. You got A, C, B, this angle's 63 degrees, this angle is 60 degrees, this angle's 57 degrees, and they want them listed from shortest to longest again. And just looking at the way they have them listed, they just use commas instead of the alligator mouse, so I'll do that. The shortest one has to be across from the smallest angle, so that's got to be segment CB. The next shortest one is across from the 60 degree angle, so that would be segment AB. And then the longest one's across from the 63 degree angle, so that'd be AC. Let's see if any of those, let's see, segment CB, segment AB, segment AC. That looks like letter C on the answer, or on the packet. Problem 14. Problem 14, they say complete this. Measure of angle 1, and they give you a blank. Measure of angle 2. So is angle 1 the same as angle 2? Is it bigger than angle 2? Is it smaller than angle 2? We're going to put in either greater than, less than, or equal to. The two triangles they give us, one triangle looks like this. Those two sides are congruent. This is angle 2 right there. That's 19. Then they give us another triangle that looks like this. Those two. So this side is congruent to that side. This side is congruent to that side. This is angle 1 right here. They tell us this is 18. Angle 1's across from the 18 degree, or the 18 length side. Angle 2's across from the 19 side. So that tells us that angle 2 has to be the bigger angle. So the symbol that would go in here is that angle 1, if angle 2 is bigger, angle 1's got to be less than angle 2, which is letter B. Notice I didn't make a comment about that. Number 15. These two got those marks on it. That's B, C, and A. This is marked that way. That's 75 degrees, Z, Y, and X. And again, they say segment 8. No, that's the wrong problem. Segment AC, they give you a blank, and segment XY. It's supposed to be a Y. So we look at these, got these two sides congruent to these two sides, so we can look at the angles. The bigger angle has to be across from the longer segment. Well, these two angles happen to be the same. So that tells us that these two sides have to be the same. So the symbol that should go in there this time is equal to, and that's letter A. No. C. My fault. Looking at the wrong one.
Fine. Well, it doesn't look like you.
16. Seems like I remember doing these. $71. This is 70 degrees. And they want to know segment AD and how it's related to segment CD. A is here, D is here, C is here. So AD is across from the bigger angle than CD is. So that means that this right here has to be longer. So the symbol is going to go in there as greater than, which is letter A. 17, you and your brother are going different places for the holiday, but you both start at your house. So I'm going to do it like this. This is H for home, and you go 25 miles due north. So 25 miles, that's that. You fly at a 15-degree angle to the west. So this angle's 15 degrees, and you reach your destination, which was 225 miles from the airport. Your brother flies to the east, and he flies 225 miles, the same that you flew, but he flew at a 25-degree angle. And they want to know which one of these two distances is the longest. Is your brother, we'll call this U for you, this is your brother, so B, is your brother farther from your house, or are you farther from your house? Don't go by my drawing. We look at this, we know that these two are congruent to each other, you both flew the same distances. We also know that you both drove the same distance to get to the airport. So we have a pair of sides, another pair of sides, because anything equals itself here, and then we can compare the angles. Your angle was smaller than your brother's, so that means this side in your brother's triangle has to be greater than yours. So the distance he is from your house is bigger or longer. So we look down at the answers, and it says your brother is farther from home. That's letter C. Number 18. Number 18 says a triangle has one side that has a measure of 1 foot. Be careful on these. And then it has another side that's a measure of 20 inches. Which are possible sides lengths for the third side. So we're looking for what this third side should be, or could be. We had a theorem that said any two sides of a triangle must add up to be more than the third side. The bad thing here is you got feet, you got inches. We need to change it. So we're going to make this 12 inches and get rid of the feet so that we're looking at the same thing. The third side, I'm going to write it like this with the alligator mouse. To find the low end of the third side, all you do is take the two sides and you subtract them. So 20 minus 12. So that could be 8. Yeah, you can do it. Okay. Grace, you can give Grace hers. I know this is still recording, so to do the low end, 20 minus 12, that gives you 8. I know you can't see the picture right now, but then to do the high end, you do 20 plus 12, which is 32. So the third side has to be between 8 and 32. If we look at the answers that they gave us there, it's got to be between 8 and 32. Letter A is 3. Well, that's not between 8 and 32. Letter B is 28. So that's a possible answer. Now, we don't just stop there because it could be more than one. Letter C is 6. That's not between 8 and 32. Letter D is 36. That's not between 8 and 32. So the only possible answer for this one is letter B. Letter B. Number 19. Number 19, sort of the same setup. They give you a triangle. Tell you this side's 2 feet. This side's 11 inches. Same idea here. We can't use the 2 feet. So 2 times 12 is 24. We just change it over to inches. We're looking for that third side. Again, we can figure out that the third side has to be between two numbers by subtracting those for the low end. So 24 minus 11, which is 13. And on the other side, 24 plus 11, which is 35. So the third side has to be between 13 and 35. Letter A is 38, that's not. Letter B is 7, that's not. Letter C is 6, that's not. Letter D is 16. So the only one that will work in case of number 19 is letter D. Problem 20. Triangle has one side that measures 3 feet. Another side that's 38 inches. So I'm going to write down the 38 inches. I'm not even going to write down the 3 feet. I'm just going to do 3 times 12, which is 36. So that's 36 inches and 38 inches. Find the third side. Lowest it can go is 38 minus 36. So that's 2. The highest is 38 plus 36. And that is 74. So it's got to be between 2 and 74. We look at the answers. 1's not between 2 and 74. 58 is, so B will work. C is 93. That's not between 2 and 74. D is 80. That's not between 2 and 74. So B is the only answer that will work. 21. Let's erase all this. 21, 22, 23, 24 all sort of go together. So I'm just going to write all these up here. I'm going to draw the picture for each one. They give us triangle ABC on each one. And on 21, they tell us AC is 10, BC is 28, and AB is 15. 22, they tell us AC is 27, BC is 34. Don't go by my drawings, they're not drawn to scale. AB is 14. AC on 23 is 39. BC is 13. And AB is 29. And AC is 20 on this last one. BC is 14. And AB is 21. So all I did was I just drew the picture for all 4 problems there. And then they want us to match it up A, B, C, D for each one. First thing says angle B is the largest angle. So apparently there's only one of these where angle B is the largest angle. If angle B is the largest angle, that means it's got to be across from the biggest side. Well, if I look at this first one, angle B is across from 10, so that can't be it. Here, angle B is across from 27. 34 is bigger than 27, so that can't be it. Angle B here is across from 39. That's the longest side, so B would have to be the biggest angle. Let's check the other one just to be sure. Angle B is across from 20. Well, 21 is bigger than that. So angle B is the largest angle in only problem 21. So answer to, or 23, sorry. So the answer to 23 is A. Next one says angle A is the largest angle. If I look here, angle A is across from 28. It looks like it in that one, so maybe this one. Let's look at angle A here. Angle A is across from 34. Well, that one also. So it looks like angle A is the largest angle in 21 and 22. Angle A is across from 13 here. That's the smallest. So that's not going to be it. It's across from 14 here, which is smallest. So it's got to be one of the first two here, 21 or 22, that angle A is the largest angle. But something's not right here because there's only one answer that should work. So then I look at this triangle, and I look at 15 plus 10. I take those two sides of that triangle and I add them up, and that should be greater than the third side, which is 28. Well, 15 plus 10 is 25. 25 is not bigger than 28. This triangle here is not even a triangle. And letter D said the segments don't make a triangle. So number 21 has to be D because it can't be a triangle. And then that means this one has to be B. And if this is A, that's B, that's D. You can probably guess that this one is C. I'm guessing C is the largest angle. If we look here, C is across from the longest side, so C would have to be the largest angle. That goes there. $25. I'm not going to draw the graph and everything. They give us a triangle. It looks like this. They tell us M and N here are midpoints. That means that this segment is a mid segment. This is S, this is T. And they want us to find the length of this mid segment and the length of this side. Well, we're on a graph, so we're going to have to use the distance formula. I'm going to find the coordinates of S. Coordinates of S right here are -3, -3. And the coordinates of T are 3, -1. And all I'm going to do is I'm going to use the distance formula to find the length of segment ST right there. So ST, using the distance formula. Remember, your distance formula always looks like this. A minus is in there. You put the X's in the first set of parentheses, Y's in the second set. Our X's this time are -3 and 3. So -3 minus 3. Our Y's are -3, -1. So -3 minus 1, that's going to turn into plus there. If you have your calculator, and you can do it on your calculator, that's fine. I don't have my calculator here handy, so I'm just going to do it out longhand. -3 minus 3 is -6. And this is the work you should show me. When it says show your work, -3 plus 1 is -2. Don't let your calculator lie to you. -6 squared is a +36. -2 squared is a +4. Add those two together and you get 40. And we take the square root of 40. It doesn't come out all nice and even. It comes out to be something like 6 point. So length of segment ST is 6.32. 6.32 is the length of ST. I'm going to have to restart this again. So it's 6.32. Then the other MN is a mid segment. Well, it's got to be half of that. So you just take half of 6.32, which is 3.16. So the answer, the two answers are 6.32 and 3.16. Those are the two links. 6.32 and 3.16. skip a little space here because I gotta wait for my thing to come back up, so it'll be a few seconds that you can just skip over in the video. All right, on problem 26, they tell us that segment JK is 10x minus 12. So that's that segment. They tell us that this segment and this segment are medians. So that means that M is a centroid, and they tell us that JK, if those are medians, that tells us that JK is a mid-segment. They also tell us that this segment down here is 9x plus 18. And they tell us that JM is 21. That's right here, that's 21. And KM is 23. KM, that's over here, that's 23. And segment AJ is 60. That's right here. And they tell us that segment BK is 52, that's right there. So looking at all this stuff, just different things we know, if JB is a median and this part is 60, this has to be a midpoint, that part has to be 60. AK is a median, so if that's 52, this part has to be 52. I'm not even sure what they're asking us to find. I know it's got part A, part B, part C. I'm just going to find all the stuff that I can find right now. Then we'll worry about answering the questions. They tell us that this is a median, so we know that's a centroid, and this part from here to there has to be half as long as this part. So to get from M to B, which is double that 21, so that part right there has got to be 42. Same thing here, if that part's 23, we double that, and that's got to be 46 down here. We know probably the hardest thing on this problem for most students to understand is this segment has to be half as long as that. Well, we could take half of this 9x plus 18 and set that equal to the 10x minus 12. But if you take half of 9x, you get like 4.5x. That makes it a little harder. So what I would do here is this segment up here, if you double it, that's going to give you the same as this right here. So if we double this right here, that would be 20x minus 24. And that doubled should equal what we have down here, which is 9x plus 18. And then we're just going to solve that. I'm going to solve this pretty quickly. Subtract 9x on both sides. We end up with 11, that's an x. We end up with 11x. I'm going to go ahead and move the 24 over to add 24 to both sides. We end up with 11x, those cancel out. 18 and 24 give us 42. Divide both sides by 11. I hope I didn't confuse you when I did two steps at once there. Just didn't want to mess around. They say round your answer off to the nearest tenth. So 42 divided by 11, if I grab my calculator, comes out to be like 3.8. So that's what x equals. Now, once we know that, I take it back up here, I plug in, and if I plug in right here, just because that looks easy, 10 times 3.8 minus 12, that's a 3.8 minus 12. Well, 10 times 3.8, you just bump the decimal over one place, so that's 38 minus 12. So this segment's 26. And if that's 26, if that mid segment's 26, then that means segment AB down here has to be twice that, which is 54. So that segment there is 52. Now, if we look at what they asked us to find, they said find segment JK. So for part A, JK, we just found right there, it's about 26. And segment AB, and segment AB is this down here, that was 52. Then part B said, find the perimeter of triangle ABC. ABC is the big triangle. ABC, that's this whole triangle. So all I want to do is I want to add up all of these parts going around the outside. This side over here is 52 and 52, that's 104. This side over here is 60 and 60, that's 120. So I'm just going to add up 120 plus 104 plus the bottom side, which is 52. I'm going to add all three of those, and that's going to give us the perimeter. That'd be 6, 7, 276. So the perimeter of that, I don't think they gave us any units, so the perimeter is 276. Then part C says, find the perimeter of triangle ABM. ABM is this triangle. Well, I know it's 52 on one side, 42 on this side, and 46 on this side. I'm just going to add those up. That's 10, carry the 1, that's 9, 10, 140. So the perimeter of that smaller triangle is 140. All right, problem 27 is basically the same kind of problem as 26. And I've already labeled everything on here. They tell us that this is a median, JB is a median. Well, if that's a median, then J has to be a midpoint. And if this is 34, then this part up here has to be 34. They tell us that AK is a median. So if this part's 33, that's a midpoint there. That part has to be 33. If this is a median, and we have our median, our point M here is a centroid, and we have our centroid theorem, which says this part here has to be half as long as this part down here. So if we got 11 up here, this has to be double that, which would be 22. This part over here is 15, same idea down here. That means that part's got to be 30. If J and K are both midpoints, then that segment right there, JK, has to be a mid-segment, and that mid-segment's half as long as this. I'm going to do the same thing as I did on the other one. If I double this, so if I just take that whole thing times 2, and you could write it out like this, 2 times 10x minus 14, so you're doubling this segment. That should give you this bottom segment, so that should be equal to 7x plus 20. You're just setting two things equal to each other that you know have to be the same. And then if you distribute out here, I could have done this on the last one, I didn't. That's 20x minus 28 equals 7x plus 20. I'm going to solve this real quick. Move the 7x over, you get 13x. Move the 28 over, you get 48. Divide both sides by 13. You end up with x equals, and I grab my calculator, and I say 48 divided by 13. I end up with 3.7. And then I can go back up here, and this is nice again because that has a 10x in it right there. So I'm going to do 10 times 3.7 minus 14. Well, 10 times 3.7, you just bump the decimal over one place, so you get 37 minus 14. 37 minus 14 is 23. So length of segment JK right here is 23. And then the same length of segment AB has to be double that, which is 46. So if I go to A says find JK and AB again. JK, AB. I think I've found all this stuff. JK this time we said is 23. AB is this bottom segment down here, which is 46. That's supposed to be an equal sign there. Part B says, find the perimeter of triangle ABC. That's the big triangle. This side right here is 34 and 34, that's 68. This side down here is 46, this side is 33 and 33, so that's 66. So we're going to add 68 plus 66 plus 46. We're just going to add all those up. That's 12, 20, carry the 2, put 0 down there. It's 12, 14, 8. So the perimeter of the big triangle is 180. That's the answer to part B. Part C, they want us to find the perimeter of triangle ABM. That's this bottom triangle. So it's 46 plus 22 plus 30. Remember, for perimeter, you just add up all the sides. That's 8, 6, 9, 98. So the perimeter of that triangle on the bottom there is 98. Problem 28. They give us a triangle that looks like this. Segment A, or point A, point B, point C. This is 18 inches. This is 20 inches. This is 17 inches. They say for an art project you need to create a design that involves only triangles. One of the triangles you cut out is shown below. List the angles of the triangle from smallest to largest. So we want to go smallest, then the middle one, then the largest. We want to list them in order. The way we figure that out is we look for the longest side. 20 is the longest side, draw an arrow. That's got to be the largest angle, and I should have went the other way. Let's start with the smallest side. 17 is the smallest side. So that angle across from it's got to be the smallest angle. So angle A is the smallest. This is the next smallest side, the 18. So angle B is the middle one, the next smallest. And then the largest, we already said, is angle C. Hopefully that's one of the answer, or that's the answer you put in there. You just list them in order. I like using the alligator mouse, so I put angle A is less than angle B, which is less than angle C. Make sure you don't get your alligator mouse, your inequalities confused with your angle symbols. 29, same thing. It says for an art project, you want to list them from largest to smallest this time. So this time we're going largest to smallest. And we got A there, we got C there, we got B there. So make sure you read the problems carefully, know which order you're putting stuff in. So this time we want the largest one. Well, 30 is the longest side, so the largest angle has to be angle A. Again, I'm going to use the alligator mouse. This time, instead of using less than, we're going to have to use greater than. So angle A is greater than. 28 is the next longest side. That's across from angle C, so that's the next biggest angle. Greater than, then the smallest angle is going to be across from the 27. That's angle B. And that right there should be your answer. Again, if you listed your answer, angle A, comma, angle C, comma, angle B, because they told you to list them from largest to smallest, I would accept that. Problem 30. Triangle has two sides that measure 9 and 27 inches. Describe the possible lengths of the third side. To describe this, so we got a triangle, one side's 9, one side's 27. We don't know what the third side is. To describe it, I'm just going to use a compound inequality. The low end down here, the low, that side, this third side can go to, the length of it. We just take the two sides and we subtract them. So 27 minus 9, which is 18. On the high end, all you do is you add those two, 27 plus 9, which is 36. So our description of that third side, if you wanted to explain it out more, the third side must be between, it can't be 18 and it can't be 36, it's got to be between those two numbers, so 18 and 36. Thirty-one says, is it possible to construct a triangle with the sides 35, 23, and 62? If not, explain why not. So the way we're going to check to see if that's possible for a triangle is we just pick two sides and we add those two sides together. So we say 62 plus 23, and that's got to be, any two sides got to add up to be more than the third side, which the third side this time is 35. 62 and 23 give you 85. 85 is bigger than 35, so that checks out. But to be a triangle, we got to make sure for all three parts. It's got to work for all three ways to match up the sides. So I'm going to try 35 plus 23, and that should be greater than 62. Well, 35 plus 23 is 58. That's not bigger. So it's not bigger than 62, not greater than 62. So for this is not, can't be a triangle. So what we say here is cannot, our explanation cannot be a triangle because 35 plus 23 is not larger than 62. So if any two sides don't add up to be more than the third side, then it can't be can't form a triangle. That would be our explanation there. Next one, problems 32 through 36. 32 to 36. Let's see what it says here. All right, so I got this all drawn out. They tell us that segment XD is congruent to segment YD. So that means this is a midpoint, D is a midpoint. They tell us that segment XF is congruent to segment ZF, so that tells us that's a midpoint. And then they tell us YE is congruent to EZ, so that means that's a midpoint. If that's the case, that connects to midpoints, so it's a mid-segment, that's a mid-segment, that's a mid-segment. And knowing all that, we know that the length of this is half as much as the length of that. So if that's true and F is a midpoint and these have two tick marks on it, then DE has to have two tick marks. So all three of those three segments have to be the same length. And we can do the same thing for the others. This segment DF has to be half as long as that. Well, half of it has three tick marks on it, so we can put 3 on there. Same thing on this side, that has to be half as long as that one there, so that can have 1 tick mark on it. And the other thing we know with that is that segment DE here is parallel to that side. Segment EF is parallel to this side, and segment DF is parallel to that side. So we should be able to go over here and fill all these in. First one, they say segment DE is parallel to what? Well, the segment it's got to be parallel to is that one right there, and there's several different ways we could name it. I'm just going to name it segment XZ, segment XZ. Then the next one says YX, that's this, is parallel to, that's that one there, so I'm going to name it segment EF. If you used a line instead of a segment, that would work also. Then they say DY is congruent. DY is right here, it's got one tick mark. It's congruent to, well, it's congruent to segment XD, and we know it's congruent to segment EF. Then the next one says DF. DF is right here. The two segments it's congruent to, YE and EZ. So YE and EZ. And 36 says DF is parallel. So this segment is parallel to, well, that's this segment right here. So segment YZ. Thirty-seven says, they give you this triangle. I'm just going to draw the triangle, then I'll read the problem. This is B, that's D, that's a right angle, that's congruent to that, that's A, that's C. First thing I know before I even look at anything else, forms a right angle, so it's perpendicular to it, and it bisects this segment AC, so it's a perpendicular bisector. We had a theorem that said any point that falls on that perpendicular bisector has to be the same point, or I'm sorry, same distance from point A as it is from point C. Well, B is on that perpendicular bisector, so that's telling me that this segment AB has to be the same length as segment BC. I'm not sure what they're asking me here, but we'll figure it out. It says in the diagram of the formal garden, east and west path is perpendicular to the north path, and segment AD is congruent to segment CD. What can you conclude about segment AB and segment CB? Explain why. So I just did that. So I'm going to say segment AB, this is going to be our explanation, is congruent to segment CB. And our reason is because B is on the perpendicular bisector of segment AC. So B is equidistant, or the same distance, equidistant from the two endpoints, which is from point A and point C. That's our explanation. .38 says in the diagram, fire hydrants located at point A and B, line PQ coincides with point road and is the perpendicular bisector of AB. Will a firefighter at the scene of a car fire have to walk farther to connect the hose to fire hydrant A or fire hydrant B? So they give us this picture. You got B down here, you got A up here. The car fire is here at P. And this is Q out here, that's the road. So they're telling us that this is the perpendicular bisector of this, so there's a right angle there, and we know that these two segments are congruent. And they want to know if the fireman walks to A or walks to B, which is the shorter path. And our answer is going to be both distances are equal because P is on the perpendicular bisector of segment AB and is equidistant from A and B. Number 40 says, you and two of your friends deliver newspapers. You and two of your friends deliver newspapers in your neighborhood. Newspaper distributor wants the pickup box to be the same distance from each person's house. Explain how you can use the diagram to locate the pickup box. So you got your house. I'm going to make that a U. That's right here. You got one of your friend's house. It's right here. I'm going to put that as your first friend. Then you got your second friend's house. It's somewhere like in here. I'm going to make that an S. So you're trying to find a spot in this triangle where they can put that pickup box so that all of you have to walk the same distance to get to it. But we had a theorem that said these are the corners. Your house, your friend's houses are the corners of the triangle. So we had a theorem that said that there's some certain point that's the same distance from all the corners. And that point was the circumcenter. So what you're going to have to do is find the circumcenter, center of the triangle, because it is always the same distance, it's an I there, distance from the three corners of the triangle. So you find the circumcenter because it's the same distance from all three corners. If we wanted it to go to the sides, remember that's the in-center theorem. So if we were trying to find the distance from here to the sides, that would be a different thing. That's the in-center theorem. Problem 30, oops, sorry, I skipped problem 39. I'm going to go back to it. Problem 39. When a king truss is built correctly, point P lies on the bisector of angle ACE as shown in the diagram. How can a carpenter use the supports segment PB and PD to make sure that P is in the correct position? So they give us this, ignore that straight part there, looks something like this. A goes here, we got something come down here, that's P, we got this, that's B, and this is C, we got something coming up here, that's D, that's E. A king truss is what goes in a roof when you want it to have a little more support. A lot of trusses just have just something like that. A king truss actually puts in those to make it have more support. And again, they tell us that P lies on the bisector angle ACE. So we got angle ACE, that's this angle. So that's on the bisector, so these two angles have to be congruent, is what they're telling us. And they want to know, how can a carpenter use the supports, this and this, PD, to make sure that P is in the correct position, to make sure that it's the same. Well, what should happen, if this is an angle bisector, then this distance and this distance have to come out here and form right angles, and they have to be congruent to each other. Because any point on the angle bisector, so P's on the angle bisector, has to be the same distance from the two sides of the angle. So if the person building this cuts this 6 foot long, and this one's 6 foot long, and this one reaches over here and touches, and this one reaches over here and hangs over a foot, then it's not right. It's not set up right, because those two distances have to be the same. And so that's what we're going to write. We're going to write that segment PB, it must be the same length as segment PD, because any point on an angle bisector is equidistant, ignore all those stray marks, from the sides of the angle. Any point on the angle bisector has to be the same distance from the two sides of the angle. You're drilling a hole in the triangular birdhouse. You want the hole to be the same distance from all three sides. Where would you drill the hole? Explain your reasoning. Well, if we want it to be the same distance from all three sides, then where we're going to drill it is at the end center. And our explanation is going to be because the end center is always the same distance from all three sides of the triangle. The end center is always the same distance from all three sides of the triangle. 42. Landscaper plants magnolia tree in a triangular courtyard shown tree. He wants to make sure the tree will be the same distance from all three border lines. So again, he's got this. He wants to plant the tree in here somewhere. He wants it to be the same distance from here as it is from there, as it is from there. Well, your answer for 42 is, where is he going to plant it? That's your answer for 42. He's going to plant it at the end center because he wants it to be the same distance, because the end center is always the same distance from all three sides. They give us a picture, it looks like this. Oops. Looks something like that. That's not very good, but they say P is right here, and they give you something that looks like this, and they tell you that that's 5 centimeters, and they go over here, and they tell you that's 5 centimeters. Well, if that segment's 5, that one's 5, and they're both perpendicular to the sides of this angle, then if we go from this corner and we go through that, it's got to bisect that angle. That was one of the theorems that we had. It's the converse of the end center theorem. So they ask us, can you conclude that the segment bisects angle ABC? And our answer is going to be yes. because if a point is equidistant from the sides of an angle, then it must be on the angle bisector. So it's just the reverse of what we said on some of the other ones, or the converse, not the reverse. 44. All right, on 44, they tell us first segment, or I'm sorry, they tell us that V is a centroid. If V is a centroid, then all these segments are medians. So we know like this segment has to be congruent to that segment. Again, don't look at my picture because it's not drawn very well. This segment has to be congruent to that one. This one has to be congruent to that one because N has to be a midpoint. And we know that this segment is twice as long as that segment, so on, so on, so on. So we should be able to find all this. They tell us first that TP, that's this whole thing. TP is 18. Well, if that whole thing is 18 and you want to split it up into threes, into three parts, we want to split it up evenly because from the angle to the centroid is going to be two of those parts, and from the centroid to the midpoint down here is going to be the other one. And what we're looking for is this part right here. So when we split up 18, it splits up into 6 and then 6 and 6. So this part over here would be 12. They didn't ask us about that part. They asked us about this part over here, which that means x is going to equal 6. So this part right here is 6. Then they tell us MS, that's this one, is 15. So if we take 15 and we split it up into three parts, that'd be a 5, a 5, and a 5. The short part's going to be 5. The longer part's going to be those two together, which is 10. They wanted this part right here. No, I'm sorry, I'm on the wrong one. They wanted this part right here. So they wanted the shorter part, so y equals 5. And then the other one, Rn, that's this one. They tell us it's 24. Again, they wanted the shorter part. Well, 24 splits up into three parts by being 8, 8, and 8. So the longer part is 16, the shorter part is 8, so Z has to equal 8. And those are your three answers. Uh, 45. 45 gives you a picture of a triangle, looks something like this. That's E, that's G, that's F, that's D. They tell us this is 3x plus 1, and this is 5x minus 17. And they tell us that segment EG is a median. Well, if it's a median, that means G is a midpoint, means that these two segments have to be congruent to each other. So the equation we can set up is 5x minus 17 should equal 3x plus 1. We subtract 3x on both sides, end up with 2x minus 17 equals 1. Add 17 to both sides. 2x equals 18. Divide both sides by 2, you end up with x equals 9. What they ask us to find? They say find x. So they just wanted us to find x. Our answer for this one is x equals 9. I have two blanks here. I'm not sure why. Just ignore the second blank. 46. Says find X, and they give you this, and they tell you that SU is a median, so it's sort of the same idea. If this coming down through here is a median, then that means this part has to be congruent to this part. So the equation we're going to set up, remember that's a plus sign, not a division sign. 2x plus 24 has to equal 5x minus 30. I'm going to solve this real quick. That's 3x on that side, move the 30 over, that's 54. Divide both sides by 3, and you get x equals 18. That's one of the answers. They also wanted us to find the length of segment RT this time. RT. Well, if this part is 2x plus 24, then all I'm going to do is plug in 18 there. So 2 times x, which is 18, plus 24, that's 36 plus 24. 36 plus 24 is 60. So this part's 60. Well, I don't even have to plug into the other one, because if that part's 60, this part has to be 60. And then that means the whole thing, you add those two together, the whole thing is 120. $47. Tell whether each one can be a triangle. So we got 47, we got 48, we got 49, we got 50. The first one, 4, 7, and 10. For it to be a triangle, then 4 plus 7 has to be greater than 10, which it is. 4 plus 10 has to be greater than 7, which it is. And 7 plus 10 has to be greater than 4, which it is. So the answer to 47 is yes. That one could be the sides of a triangle. Next one, 2, 9, and 12. So we do this. We just pick a couple sides. 2 plus 9 has to be greater than 12. Well, 2 plus 9 is 11. That's not greater than 12. So those can't be the sides of the triangle. All we got to do is check that one. And the answer is no on that one. Next one. 18 plus 32 should be greater than 14. And it is. Then 14 plus 18 should be greater than 32. 14 plus 18 is 32. 32 is not greater than 32. So no, there is no triangle in the world that has sides 14, 18, and 32. Next one, number 50. We pick a couple of sides here. 41.9 plus 62.5 should be greater than 103. 40, that's 103. That's 103 over there. Let's see, that's 103, 104, that's 104.4. And yes, that's greater than 103, so that one checks out, and that doesn't mean all of them work, so we do 103 plus 41.9. That should be greater than 62.5. Yeah, that's going to work. And then we check out 103 plus 62.5, and that should be greater than 41.9. And yes, that one works, so this one answer is, excuse me, is yes. That's the last one. Again, skip through them, see which ones help you. I hope I didn't skip too many of them when I messed up there at the beginning. Use them to see what you're doing right or wrong, or if you have trouble on the review packet before your test.